Welcome to the Using Node.js video series from MarkLogic University. This video is the third part in a series of topics covering the use of the MarkLogic Node.js Client API. In this video, you will describe security requirements for performing updates and deletes, describe update and delete transactions, perform update and delete transactions, describe single statement and multi-statement transactions, and perform a multi-statement transaction. To follow along with this tutorial, you'll need to download and install MarkLogic and get a free developer license. And you'll also need to download and install Node.js. And as we progress throughout this tutorial, we'll refer to various pieces of code. These examples are available through the MarkLogic University GitHub site. Now, if you think back to episode 2 of the Using Node.js series, we discussed that when writing documents to the database, you can manage permission metadata on those documents, including insert, read, update, and execute permissions. In order to perform an update or delete transaction on a document, the user must have a role with an update permission on that document. Out of the box, MarkLogic provides some pre-built roles for working with the REST API, specifically a role called REST Reader, REST Writer, and REST Admin. And because our Node.js middle tier communicates to our database using our REST instance, we can also take advantage of these default roles. So, in order to update or delete a document, your database client needs to authenticate as a user with the REST Writer role or a custom equivalent. And if you think back to episode 2 of this series, we created project-specific users and associated those users with these default REST roles. We'll continue with those same users for our examples in this tutorial as well. So let's imagine a scenario where we want to update a document in our database and change the value of a specific JSON property. Specifically, let's say we want to change the name property of our tofu soup recipe from episode 2. We want to change the name from its original value of tofu soup to something more descriptive like vegetarian tofu soup. One way to accomplish this goal would be to build an entirely new document descriptor for this recipe and write it to the database at the URI of the existing tofu soup recipe using database client.documents.write. When you write a document to the database at a URI that already exists in the database, you're performing an update. However, to implement this approach, you would have to rebuild the document descriptor in your application and manipulate the data that you wish to change before writing it back to the database. Now, this is a valid approach to perform an update, and you might choose this approach if you have already read the document descriptor into your app. In this scenario, it makes sense to simply modify your document descriptor as needed in your app, and then write it back to the database. But if you haven't already read the document descriptor into your app, performing a patch or partial update would be a more efficient approach from both a coding and execution perspective. Using the MarkLogic Node.js Client API patch functions, you can tell MarkLogic Server what update to apply and where to apply it. This enables you to easily update specific document content and metadata. And out of the box, MarkLogic provides 4 different patch operations: insert, replace, replace insert, and remove. And should you require additional operations, we have hooks that exist that would let you implement a custom patch to meet your specific application requirements. When performing inserts and updates, you may wish to determine whether or not a document already exists at a given URI. Probe is a lightweight way to achieve this goal without actually having to go out and fetch the document from the database. Simply pass database client.documents.probe a URI, and it will return a document descriptor. The exists property in the document descriptor will be true or false, telling you whether a document already exists at the given URI and enabling you to react appropriately based on your specific application needs. Now let's take a look at these concepts in action. In our first example, we'll see the use of probe, write, and a patch update. And remember, you can find this example on the MarkLogic University GitHub site if you wish to follow along at home. So let's take a look at the code. We'll start with a quick look at our project's package.json file. Remember that to set up your project, you'll need to do an npm install from your local project directory to install all of the defined dependencies. For these examples, all we really need is the MarkLogic Node.js client API. Next, let's take a look at connections.js. Remember that in this episode, we are going to use the same configuration that we created back in episode 2 of this series, which includes a REST instance on port 6000 and 3 different users who have each been given one of the default REST roles. Now let's take a look at the code in example1.js. First, you'll note the basics. We import the MarkLogic Node.js client API, and then we create our database clients. Then you'll notice something new. We're creating an instance of MarkLogic.patchBuilder. This will then enable us to build patch operations in order to perform patch updates on a document. Next, you'll see that we define a variable to represent the URI of the document that we'll be working with in this example. And we see the definition of the document itself, which is a simple recipe for mashed potatoes. Take notice that the value of the name property defined here in this document is simply mashed potatoes. The first thing that this code will do is probe the database to see if a document exists at the URI we have defined. Note that in order to perform a probe, you only need to be a user with a role that has a read permission on the document. So it's a general best practice to authenticate as a user with the minimum permissions required to perform the task at hand. Therefore, we're going to use our dbRead client in order to do the probe. If the results of the probe tell us that the document does not exist in the database, then we are simply going to insert the document into the database. But if the results of the probe tell us that the document does exist in the database, then we are going to perform a patch update, making a change to the name property of our recipe. Specifically, we're going to change it to garlic mashed potatoes. Finally, the code will read the document and output the value of the name property. So let's run it. Now, the first time we run this code, probe will tell us that this document does not exist in our database. So our code will insert the document as originally defined. So let's run it here at the command line. And we see the results. The name property is equal to mashed potatoes. Now let's run this code a second time. And in this iteration, probe will tell us that the document does exist in our database, so our code will perform the patch update. So from the command line, let's run node example1.js one more time, and we see that the name property gets updated and is returned to us now as garlic mashed potatoes. Now let's take a look at a delete transaction. A delete transaction is really an update where the document gets updated with a delete timestamp. And if you think back to our security discussion, this makes sense, as there are no delete permissions on documents, only update permissions. To perform the delete, use database client.documents.remove and pass it a URI. Note that the syntax is remove rather than delete, so as not to conflict with the standard JavaScript delete operator, which is used to delete a property from an object. Once a delete is committed, subsequent queries won't see the document because by default, queries deliver a point-in-time view of the database based on the timestamp of the query. The document will be physically deleted when the forest containing the document undergoes a merge, which will happen automatically. Let's take a look at this in action. In example 2, we'll delete the document that we created in example 1. So let's take a look at the code in example2.js. The first thing we'll see is the standard import of the MarkLogic Node.js client API, the creation of our database clients, and the definition of the URI that we're going to delete. Then we see the delete transaction. We use our dbWrite client to delete the document from the database. And then we use our dbRead client to probe the database and check to see if the document exists. Finally, we return the exists property from the document descriptor that comes back from the probe to see if the document has been deleted or not. So let's run it. Over here in the command prompt, we can key in node example2.js and we'll see the result. And if we look at the result, we see that the exists property comes back as false because we have in fact deleted that document as part of the promise chain in our code. The code that we reviewed in example1.js and example2.js are examples of single statement transactions. With single statement transactions, every request is a single transaction. The transaction will automatically commit on success, or it will automatically roll back on error or timeout. But what about a scenario where you need your application to perform a transaction that is made up of multiple operations, and you wish to see the effect of those operations within the transaction, and then decide whether you wish to commit or roll back? This is possible using a multi-statement transaction. In this model, each request in the transaction sees changes made by previous requests in the transaction, but requests outside the transaction do not see those changes. With multi-statement transactions, you must explicitly commit the transaction in your code. There's an implicit rollback based on a timeout, error, or a session completion without a commit. Let's take a look at this in action. In example3.js, we'll study multi-statement transactions. Now, if you think back about what we did in example 2, you might recall that we actually deleted our mashed potatoes recipe from the database. So if you've been following along on your own machine, you're like me, you're sitting on an empty database right now. So let's start by getting that document back in the database by rerunning example1.js. So I'm going to come here to the command prompt and key in node example1.js, execute that code, and that will create our original mashed potatoes document for us. Next, let's take a look at the code in example3.js. The goal of example 3 is to create a new version of our mashed potatoes recipe with a slight few variations from the original. And we're going to do this using a multi-statement transaction. So the first things that we see in the code are the standard things that we need: our MarkLogic API, our database client connections, a patch builder instance, and we see the definition of both the current URI that exists in our database and the URI of the new document that we're going to create as a result of this transaction. The next thing we should study in our code is a function called cloneRecipe. And if we study this function, you'll note that the first thing that we do is to open a transaction. This is the start of our multi-statement transaction. Then we're going to go out and read the document from the database. This will be the original document that we have in our database. Then we're going to modify some of the contents of that document descriptor, specifically changing its URI, changing the recipe name to spicy mashed potatoes, and adding sriracha as an ingredient. Then we're going to write the contents of this new document descriptor out to our database at the new URI. Then we're going to commit the transaction, and then finally pass both the new URI and the old URI to a function called result summary. You'll notice here in our code that we also have a catch, and if we were to have an error during any stage of this execution, in our catch we would then explicitly perform a rollback. And if we study the function that's going to return our results, we can just really quickly look at that, and we'd see this function here called result summary, and this accepts a URI, and we'll go out and actually read that document back to us. So at the end of this execution, we should have created a clone of our original mashed potatoes recipe, and then we should read both the original and the clone back into our console. So let's go ahead and test it out. I'm going to go here back to the command prompt, and I'm going to key in node example3.js, and let's execute that code. And we see that we do in fact get both our original mashed potatoes recipe as well as our new cloned spicy mashed potatoes recipe with sriracha sauce. In this tutorial, you learned about the security requirements for performing updates and deletes, how to perform update and delete transactions, the differences between single statement and multi-statement transactions, and how to perform a multi-statement transaction. If you haven't done so already, please go out and take the next steps. You can go to our developer community where you can download and install MarkLogic and get a free developer license. You can complete the examples in all the Node.js episodes by going out to the MarkLogic University GitHub site. And if you need some additional training and assistance, be sure to check out our other on-demand training tutorials as well as our instructor-led courses through our website.